I'm going to look at a few examples just to determine, looking at the data, can we figure out what kind of function it is. Is it quadratic, linear, exponential? So I'm going to do 4 sets of xy pairs in boxes, but they can also just be written as pairs. -2, -1, 0, 1, 2, and the corresponding y's are -6, -6, -4, 0, 6. So in this example, when you first look at it, you can see that it's probably not linear, because -6 plus 0 is -6, but then -6 plus 0 is clearly not -4. So that's just not going to work. We can also look at it and say, could it be exponential? Well, it doesn't look like it's going from very, very small to very large. So our only possibility really is whether it could be quadratic. And it's either quadratic or it's just random data that just doesn't fit. But we'll give it a shot and see if we can find the first and second differences. So looking at first differences, -6 minus -6 is 0. -6 minus -4 is -2. -4 minus 0 is -4. And then 0 minus 6 is -6. So this is our first differences, but you can never tell with a quadratic unless you get to the second differences. 0 minus -2 is +2. -2 minus -4 is +2. And -4 minus -6 is +2. So based on the second differences, yes, you have a quadratic equation. Okay. Let's look at the next set of data. These values also have x minus 2, minus 1, 0, 1, 2. With the corresponding y values of -2, +1, +4, 7, and 10. So we can see again the x values go up by 1, but what's happening to the y values? Well, we're going to do what we usually do and start with linear. -2 plus what is 1? -2 plus 3, it looks like, right? Will give us +1. 1 plus what equals 4? Well, again, +3. 4 plus what is 7? +3. And 7 plus +3 is 10. So that was an easy one. That is a linear equation. Okay. So I'm going to start with guided practice 1 and 2 down here by drawing you the data. So guided practice 1 gives us data. And they only give us 4 x values this time. 0, 1, 2, 3. And so when x is 0, y is -1.5. When x is 1, y is -0.5. X is 2, y is 2.5. And when x is 3, y is 7.5. When we look at this data, again, we see if I'm looking at a linear equation, which is what I always check first, right? -1.5 plus what is -0.5? Well, clearly plus 1, right? So let's try the next one. -0.5 plus 1. That'll give me +0.5, not +2.5. And it certainly won't work for the last two. So it's clearly not linear. it is start going from small to big, but I don't see anything that it's multiplied by that would give me an exponential equation. Negative 0.5, let's see, times, so it's more, it'd be like divided by 3 will give me negative 0.5, right? But then if I divide by 3, it's not going to work. So clearly not exponential. So we're down to, is it a quadratic? And we have to try our first and second differences to make sure. So negative 1.5 plus 1 we determined gives us negative 0.5. Negative 0.5 plus, let's see, plus 3 will give us 2.5. And 2.5 plus 5 will give us 7.5. So that's the first difference. Let's look at the second differences. 1 plus 2 is 3, and 3 plus 2 is 5. And we can show right here through the second differences that this has to be quadratic because the second differences are consistent. The last problem, guided practice 2, also gives us only 4 values for x. Negative 2, negative 1, 0, and 1. Okay, and then y is 0.08 and 0.4 and 2 and 10. And I am sure that by the time I wrote down 10, all of you know exactly what function this is because you've seen this before. So we can go through the process and rule everything out, but if I were in class and paused and asked you right now, I am almost sure you would say it's exponential because you're going from 0.08, very small value on the y, to a very high value on 10. But we do have to prove it. So let's see. If that's true, 0.08 times something would equal 0.4, and that would be the same number everything's multiplied by. So 0.08 times, it looks like 5 equals 0.4. And 0.4 times 5 does equal 2, and 2 times 5 does equal 10. And so yes, this is indeed an exponential equation. So this covers problems 8 through 11 in the homework. And this portion is not too difficult. It's really just identifying the equation. In the next part, we're going to do what we've done before, and from this data, we're going to write the equation. And I'm going to give you the steps to do that.